Okay, so we've done the CR conditions, and we know that the CR conditions are not something which is sufficient condition for the differentiability, but it is necessary condition, right? Can anybody tell me what is the CR condition? What are those?
So ux equals to vy
Yes,
and uy equals to minus vx.
yes. These are the necessary condition, and we have derived that, right?
Yes, sir.
So we have derived those CR conditions. Now let's see that how the functions are differentiable. I mean, how even if the CR conditions are satisfied, even then the function may not be differentiable at that, right? So that is fz is equal to z bar square upon z when z is non-zero, 0 when z is 0, right? So all you need to do is what you need to find that the CR conditions will hold in this case, but the function will not be differentiable at this case. Okay, so in the last lecture we have done those CR conditions, and we have verified for this example that for this example CR conditions hold at xy00, right? Now we'll prove that this function is still not differentiable even if the CR conditions hold, right? So let's try to find out this. So let's say we want to find out the differentiability at z is equal to 0. So we need to find out this thing, right? Fz minus f0 upon z minus 0. If this limit exists, we'll say that the function is differentiable, otherwise not, right? So that is nothing but the f dash 0. Okay, if it holds, right? Only then. Okay, so now, so this will be limit z goes to 0. Fz would be z bar square upon z. F0 is given to us, that is 0 upon z minus 0. So we can write it as limit z goes to 0, z bar square upon z square. So if your z is any complex number, we can write z as x plus iota y. So that will become limit xy goes to 0, 0. Since it is z bar, so x minus iota y whole square upon x plus iota y, right? So now, if you prove that this limit is path dependent, we'll using that two-part test, and then we'll say that this limit does not exist, then we'll be able to conclude that this differentiability doesn't hold. That means the function is not differentiable at z is equal to 0. Consider
Sir,
y is equal to mx.
excuse me,
Yes,
sir.
हाँ जी.
सर x प्लस आयोटा y का स्क्वायर नहीं आएगा?
यहाँ पे हमारे पास z बार है ना, तो z बार क्या हो जाएगा, x माइनस आयोटा y हो जाएगा, ठीक है?
सर नीचे वाले में,
ओह
नीचे
सॉरी,
सेट स्क्वायर है ना?
हाँ हाँ नीचे वाले में, सॉरी नीचे वाले में आएगा. ओके, फेयर इनफ. सो नाउ लेट्स से y is equal to mx. So limit, we'll write it as limit x goes to 0, and we'll replace our x mx okay. So that will be limit x goes to 0, 1 minus iota m upon 1 plus iota m whole square. Right? You're with me?
Yes, sir.
So that is simply, we can, we don't need limit over here since we are able to remove the x. So now this is something which is not unique, right? Which is not unique. So what does that mean? क्या कहोगे?
Limit does not exist.
Limit does not exist. So which limit does not exist? This limit does not exist, right? So that means differentiability is not there. The function is not differentiable at z is equal to 0. That's what we wanted to prove, right? Are you with me on this?
Yes, sir.
Yes. Okay. So now we do few more examples where we say that the CR condition satisfied, but the function is not differentiable. Okay. So I'll do few more questions on that. Fz is given to us, that is this thing. Okay. So we need to check that CR conditions are satisfied at 0, 0, but the function is not differentiable at 0, 0, right? So let's say first of all we prove that this function is, this function satisfies the CR conditions. Okay, so what are the CR conditions? Tell me.
So ux and vy.
True. So we want to find out the CR condition. We want to determine them at this point. So that means we need the partial derivative at this point. So that means we want ux at 0, 0, uy at 0, 0, vx at 0, 0, and vy at 0, 0. Okay, so first of all, we'll determine these four things, right? So what we're gonna do, we'll find ux at 0, 0, which is nothing but that is limit h goes to 0 u x, and what is that point? Tell me. 0, 0 है ना point. X naught y naught 0, 0 है तो 0
Yes,
plus
sir.
h 0 minus u 0, 0 upon h. Just tell me what is your u?
So function fz.
fz क्या होता है? uxy plus iota हाँ यही
Yes,
होता है
sir.
ना?
Yes, sir.
So what is your u? U is your real valued function?
Under root of x.
Yeah. So we have that root xy plus iota times the 0. Okay.
Yes, sir.
So this complete is your u, and this v will be nothing but 0, right? You're with me? तो अब सोचो, अगर मैंने ये निकालना हो लिमिट h goes to 0 u h 0 माइनस u 0, 0, तो 0, 0 डालेंगे तो क्या हो जाएगा? 0 ही हो जाएगा अपॉन h. एंड व्हाट विल बी योर u h 0? बोलो.
Sir, 0.
Sir, 0.
Of course, you'll put 0 over here, h over here, and 0 over here. So the product will be 0, right? So that means you will have this thing to be 0. Okay? 0 minus 0 upon h. So we are left with 0 only. So similarly, if you want to calculate uy 0, 0, so that will be limit h goes to 0, u 0, and here you'll get 0 plus h, right? Or sometimes we may take k, right? Just for the convention कि भाई हम y में कर रहे हैं इसलिए. Otherwise, I mean h can also work. So 0, 0 upon h. So limit h goes to 0. Since this is uxy is nothing the product of x and y, and we've taken the modulus and then the square root. So the product of these two things will be nothing but 0. u 0, 0 will be again 0. So we are left with 0. Similarly, if you calculate vx 0, 0, so that will be limit h goes to 0, v 0 plus h 0 minus v 0, 0 upon h. So limit h goes to 0, VH0 minus V00 upon H. Since your complete V is 0, so this will be nothing but 0, 0, 0. Similarly, if you have Vy at 0, 0, this will also become 0, right? Are you getting this point?
Yes, sir.
Yes. So now, what does it mean? You get all those things 0, 0. So of course, your Ux is equal to Vy and your Uy is equal to minus Vx since they are 0. So your CR conditions are satisfied, but we claim that our function is still not differentiable. So if it is differentiable, we need to check one thing, right? That is what? Consider the limit. Which limit? Limit z goes to 0, fz minus f0 upon z minus 0. Right? Are you with me on this?
Yes, sir.
So limit z goes to 0. What is your fz? So that is nothing but root xy minus f0 is 0, and here we'll write it as x plus iota y, right? So we should also make this thing as xy goes to 0, 0. Okay. So can you choose any path so that it will be a path dependent thing?
So y is equal to mx.
Simply y is equal to mx. That's it. So replace this by mx, and this is again mx, and then you will have x m x square and m mod x mod, right? And then you have a square root x plus iota mx. Okay, so this x will get cancelled. Let me write it more clearly. So I'll write it as x and root this. So this will be again, right? It will not be unique thing. Okay, so this will become what? Yes,
So under root mod m
yes.
upon 1 plus iota m.
Sorry, and that square should not be here. Okay, so that is under root mod m plus upon 1 plus iota m, which is again what? Not unique, right? So this is dependent upon m. Therefore, limit does not exist, right? अब हम कर रहे हैं कि this was the necessary condition, but this is not the complete condition. So what should be the complete condition in order to check that whether the function is differentiable at given point or not? Sufficient condition for the differentiability of f of z. So that means this was a necessary condition, CR condition. So in order to get a sufficient condition so that if this condition gets satisfied, then the function will always be differentiable. That's what we're gonna do. Okay. So it is that condition. We are not going to the proof of all these things. We'll only state that condition and we're gonna use that. Okay. So the condition is if uxy and vxy. Of course, uxy and vxy have their usual meanings. That means your fz should be equal to uxy plus iota vxy. So these are the actually real and the imaginary part of the function which we are considering for the differentiability, right? Uxy and vxy are continuous and have continuous first order partial derivatives. in some neighborhood of point Z, in some neighborhood of point Z, and UV satisfy CR equations at Z, then the complex function, which complex function? Fz is equal to uxy plus iota vxy is differentiable at Z. Okay, so are you with me on this?
Yes, sir.
Yes, sir.
Okay, so better I'll write it as Z naught. So Z naught means some point. Okay, Z हम उसके लिए यूज करते हैं, तो मैं I'm changing the notation to the Z naught. So let's understand in nutshell what we have discussed. That is, so if you want to prove that a function is differentiable at Z naught, you will be precisely looking at these components. In nutshell, Fz is differentiable at Z is equal to Z naught if it satisfies the following conditions. What are they? Number one, Fz must satisfy CR conditions or CR equations at Z is equal to Z naught, right? Secondly, U, V, Ux, Vx, Uy, Vy should be continuous. Some neighborhood of Z naught. Well, these two conditions should be precisely satisfied by f of z in order to make f of z, in order to declare f of z as a differentiable function at z is equal to z naught. Analytic function. Now, what is that analytic function? So we'll say that a function f of z is said to be analytic at z is equal to z naught if f of z is differentiable, if f of z is differentiable in some neighborhood of z naught. So always keep in mind here I'm taking a bigger restriction. That means I'm saying that a function should be analytic only when it should not be differentiable only at z is equal to z naught. It should be differentiable in some neighborhood of z is equal to z naught. So this is a bigger restriction, right? So in, let's say you have a point here, you have a point in the complex plane, you call it as z naught, right? So इस पॉइंट पे डिफरेंशिएबल होना मींस इसी पॉइंट पे डिफरेंशिएबल होना, दैट मींस ये तीन कंडीशन सेटिस्फाई करना, ये दो condition precisely. So I've capped these conditions in these two conditions. So ये दो conditions अगर satisfy हो जाती हैं, so we'll say that the function is differentiable at z is equal to z naught. But if you pick a small neighborhood of z naught, a small means any, I mean it may be bigger as well. So let's say you pick any neighborhood of this, right? It may be circular or it may not be circular. So this is your neighborhood of z naught. So I'll call it as neighborhood of z naught, this red one. Okay, right? So this is your neighborhood of z naught. So if there are so many points in this neighborhood, right, so many points are there, and at each of these points function should satisfy these two conditions, right? So that means condition number 1 and condition number 2. So if it satisfies these two conditions at every point of this neighborhood, then we'll say that function is analytic at z is equal to z naught. ठीक है, कहेंगे ऐसे कि z is equal to z naught पे analytic है, लेकिन चेक करेंगे पूरे का पूरा neighborhood around z is equal to z naught, उस neighborhood के अंदर आने वाले सभी points के ऊपर function क्या होना चाहिए, differentiable होना चाहिए. Differentiable होने का मतलब क्या है कि ये दोनों condition satisfy करना चाहिए. तो अब ये नेबरहुड बड़ा भी हो सकता है, छोटा भी हो सकता है, डजंट मैटर, लेकिन कम से कम एक नेबरहुड ऐसा होना जरूर चाहिए. आर यू गेटिंग माय पॉइंट? यस,
Yes, sir.
Yes, sir.
so we also call this, this thing as holomorphic function or a regular function as said. ठीक है, so always keep in mind this analytic function is also called regular / holomorphic function. Yes, is this okay? Is this
Yes,
fine?
sir.
So can you give me a small example, very small example of a function which is differentiable but not analytic, in order to make you understand the difference between the analyticity and the differentiability, right? So if you think about this function, we have done this function. So if you think about this function, we said that this function is differentiable nowhere except at z is equal to 0. याद है ये किया था ना mod z का स्क्वायर? Yes, याद है?
Yes, sir.
Right. So this function, see, fz is differentiable only at z is equal to 0, 0. That means if you draw a plane, so this is your 0, 0, right? And all other points except 0, 0, the function is not differentiable at any other point. The function was differentiable only at 0, 0. Okay. And the function was not differentiable at all other points. That means no matter how small neighborhood I choose around 0, 0, let's say I choose this neighborhood, so I'll get all those points where the function is not differentiable, right? Are you with me?
Yes, sir.
So this function cannot be analytic at z is equal to 0, 0. Why? Because no matter what neighborhood we choose, every time the function is not going to be differentiable at all those points, right? So function will be only limited to the differentiability condition rather than to the analyticity. So we'll say that the function is only differentiable at 0, 0, but it cannot be made analytic, since no matter which neighborhood we choose, for around 0, 0, we'll always get the point of non-differentiability in the neighborhood of 0, 0. Right? Are you with me on this?
Yes, sir.
So this is differentiable at 0, 0, but not analytic at z is equal to 0, 0. So can you tell me कि अगर फंक्शन डिफरेंशिएबल होगा तो क्या एनालिटिक होगा ही होगा?
नो सर.
हाँ, और अगर एनालिटिक होगा तो डिफरेंशिएबल होगा?
यस सर.
हाँ, एनालिटिक इज अ स्ट्रॉन्गर थिंग, राइट? इट इम्पोजेस एक्स्ट्रा कंडीशंस. Analytic implies differentiable, but differentiable does not imply analytic, right? Example इस चीज की क्या हुई? fz is equal to mod z square at z is equal to 0, 0. Prove that the following functions are not analytic. Okay. At any point, किसी भी point पे नहीं है ये analytic. And next is you need to check that the following are analytic. ठीक है? Show that the following functions are analytic for all z belongs to C. And that means these are find A, B, C, D so that the following functions are analytic. In real analysis, there are many interpretations of f dash x, such as slope. होता है ना slope?
Yes, sir.
Yes, sir.
Maxima, minima, etc. So what we are saying, we'll say that these things will not be carried to the complex analysis. Okay, so all we'll say that can be carried over to complex analysis. What does that mean? मैं ये कहना चाह रहा हूं कि जैसे रियल एनालिसिस में हम डेरिवेटिव को ले लेते थे ना, एफ डैश एक्स की बहुत सारी इंटरप्रिटेशन करते थे, ठीक है? जैसे हमने डिफरेंशिएशन के रूल बताए थे वो कैरी फॉरवर्ड हो गए थे ना कॉम्प्लेक्स पे भी. जैसे f प्लस जी जेड का इकट्ठे का डेरिवेटिव लें तो उसे अलग अलग कर सकते हैं. प्रोडक्ट रूल वैसे का वैसे रहता है, जो पहले था वही वैसे का वैसे रहता है. लेकिन इंटरेस्टिंगली ये सारी इंटरप्रिटेशन जो हम डेरिवेटिव्स की वहां करते हैं वो यहाँ नहीं होती है. मतलब यहाँ कॉम्प्लेक्स एनालिसिस में डेरिवेटिव का मतलब स्लोप नहीं है. डेरिवेटिव से हम मैक्सिमा मिनिमा नहीं निकाल सकते. सेकेंड थिंग इज we have done that part. Our f of z is equal to mod z square. So it's not differentiable at any point except 0, 0, right? That's what we have done. Na? Is not differentiable at any point except z is equal to 0. But on the contrary, if you turn this function into a real valued function, then you will come to know that if your f of x is mod x square and if your f of x is equal to x square, is it differentiable everywhere?
Yes, sir.
है ना? लेकिन f of z is equal to z square वो differentiable नहीं है, समझ रहे हो? लेकिन
Yes, sir.
रियल एनालिसिस में सेम चीज हर जगह डिफरेंशिएबल है, कोई समस्या नहीं है. सो दैट्स व्हाट आई एम सेइंग दैट उनकी डिफरेंशिएबिलिटी की डोमेन भी डिफर हो सकती है. जो चीज रियल एनालिसिस में हर जगह डिफरेंशिएबल है वो हो सकता है कॉम्प्लेक्स एनालिसिस में एक आध जगह ही डिफरेंशिएबल हो या एक आध जगह भी ना हो डिफरेंशिएबल, राइट? सो बट in real analysis it is everywhere differentiable. So that's it for today.